Welcome everybody, we have this interesting question. Let me draw units. BC is 7 units, AB is 5 units. So, okay, so this is 5, this is 7, and this is 4 units. Okay, so foremost, what I wish to do is I would like to utilize the chord bisector theorem. So what does the theorem states? If a line is drawn through the center of the circle to the chord, then the line would bisect the chord. So if I were to draw a line like this, then this chord, or I would say this line, would split the chord into two parts. Okay. Now what I wish to do is I would like to extend this line to form a chord. Okay. So it's actually a perpendicular being dropped. So this is going to be 90. Now clearly this side is going to be 5/2. Now what I wish to do is I would like to draw a chord from A such that the chord bisects this chord. So D, let me name this as E. So DE is a chord, and AF is also a chord. Now all of them are actually intersecting at 90 degrees. So that would mean if this division is 5/2, this division will also be 5/2. If this division is 7, this division is also 7. Okay. Now the next step is going to be, I want to extend this chord BC. Now clearly you can see that this distance is 5/2, this distance is 5/2. Then this distance will be equal to 4. Okay. Now since I've said that I'm going to extend this chord BC, this chord is going to be hinting at the point G. Okay. Now let me take this point as some x. So we will use what is called as intersecting chord theorem. So this is going to be the theorem we will be using, intersecting chord theorem. When two chords, say BG and DE, intersect at C, then the length of the chord BC times EG will be equal to DC times CE. Now DC is 4 units, CE is, this entire length is 5 units, this is 4 units, so 5 times 4, 20, is equal to BC is 7 units, and this distance is x units. Okay, So x is going to be equal to 4 times 2, 8 times 2, with 7 being there. So x is equal to 160 divided by 7. Okay, that's the value for x. Now what I wish to do is excuse me, I wish to connect the centers. Okay, I wish to, so if I were to draw a line connecting A and G, then I have a right triangle. Okay, this is a right triangle. So we need to find the diameter. So AG squared is equal to AB squared plus BG squared. Now AG squared is required, AB squared is 5 squared. This is 5 squared plus BG squared is 7 positive 160 over 7. This is the value squared. So this is 5 squared positive 49 positive 160 divided by 7 squared. This is 9 10 2097 squared plus 25. This is the value for my diameter AG. So if you were to use a calculator and find the value out, so 209 divided by 7, and you take the square of this and you add 25 to it, you get 916.45, and you have to take the square root of this. So square root of 916.45. This is approximately 30.3. So what is this? This is the diameter. AG is the diameter. Now we want the area. Therefore area is equal to pi r squared, which is nothing but 3.14 times 30.3 divided by 2 squared. So what is 30.3 divided by 2? Divided by 2, you get this, you square it, you get this, you multiply by 3.14, 719.41. 719.4 square units. So that is the area of the circle, right? So that's fine. So this is going to be the solution for this question. Now I can understand that the numbers are not whole numbers, right? You have a real number component being present there. You have to understand that that is the way real-time applications occur. We always don't get to see perfect numbers. When I mean perfect numbers like say 5, 7 like that. Because calculations, they bring in a lot of other external parameters in the picture. So we need to train ourselves in handling numbers like that. Thank you everybody. Please like, share and subscribe.